The next technology war may not be fought with chips, but with minerals. Rare earths look like ordinary materials, but they sit inside some of the world's most advanced machines. The name rare earth is misleading, because the hard part is not always finding them in the ground. Their real power comes from what they can do inside modern technology. Rare earths help make machines smaller, lighter, stronger, and more efficient. Their most important role is often hidden inside powerful magnets. A tiny magnet can become the invisible engine inside a much larger machine. Electric vehicles need strong magnets for efficient motors. Wind turbines need rare earth magnets to turn wind into electricity. Robots need magnets, motors, sensors, and precision movement. Drones, radar systems, satellites, missiles, and fighter jets also depend on advanced materials. Smartphones, cameras, speakers, screens, and electronics use rare earths in ways most people never see. Even the clean energy transition depends on hidden materials beneath the surface. That is why rare earths are not just minerals. They are hidden industrial power. The rare earth supply chain begins with mining, but mining alone is not control. Mining is only the first step in a much longer chain. Rare earths must be separated from complex ores before they can be useful. Then they must be refined into usable oxides, metals, and chemical inputs. Then they are turned into alloys, powders, and high-performance magnets. Only after that can they enter motors, turbines, electronics, and defense systems. This chain is long, technical, expensive, and difficult to rebuild. China's strength is not only that it has rare earth resources. China built the middle of the chain: separation, processing, refining, and magnet production. Raw minerals can come from many countries, but many still pass through Chinese processing. That gives China influence before the final product is even made. The real choke point is often not the mine, it is the ability to process the mineral. If processing slows down, the entire supply chain can slow down with it. If magnet exports are delayed, factories around the world can feel the pressure. This is why rare earths can become a geopolitical weapon. The weapon is not always dramatic. It can be paperwork, delay, uncertainty, and dependency. A single export license can matter as much as a shipment of raw material. An electric vehicle factory can be affected if motor magnets become harder to get. A wind power project can be delayed if turbine components face shortages. A defense contractor can worry if advanced materials become restricted. Electronics and semiconductor supply chains can also feel the shock. Companies fear rare earths because they are difficult to replace quickly. Building a new mine takes time. Building a processing industry takes even longer. Processing rare earths requires chemistry, equipment, skilled workers, permits, and environmental controls. If processing is done badly, it can create pollution and political resistance. Many countries allow the dirty and difficult parts of the chain to move elsewhere. Now they want supply security, but rebuilding capacity is not simple. This creates the rare earth dependency paradox. But cheap, clean technology can depend on concentrated supply chains. Recycling can reduce some of the pressure. Old electronics, magnets, motors, and turbines can become new sources of rare earths. But recycling cannot instantly replace large-scale production. Substitution is another strategy. Engineers can redesign motors to use fewer rare earths or different materials, but alternatives often come with trade-offs in cost, size, weight, efficiency, or performance. Stockpiles can protect critical industries for a short time. The United States, Europe, Japan, Australia, and allies are trying to build alternative supply chains. But friendshoring still takes time, money, coordination, and trust. Meanwhile, China can move higher up the value chain. It can sell not only minerals but magnets, motors, components, and manufacturing inputs. That makes rare earth leverage even stronger. Leverage is strongest when the world needs the material faster than alternatives can appear. Rare earth power does not explode, it interrupts. It can slow factories, delay products, raise costs, and pressure governments. But using this leverage too aggressively can backfire. If customers feel unsafe, they will invest harder in backup supply chains. So China must balance pressure with profit. The rare earth war is really a war over bottlenecks. Scenario 1, China keeps dominant influence over processing and magnets. Scenario 2, the United States, Europe, Japan, and allies build alternative supply chains. Scenario 3, the world splits into parallel mineral systems. The most realistic future may be a mix. China remains powerful, while others build backup capacity. Even backup capacity does not mean full independence. Small materials can create big power when every advanced industry needs them. Behind every electric motor, there is a rare earth supply chain. Behind every wind turbine, there is a mineral race. Behind every advanced weapon, there is industrial dependency. The big question is simple: who controls the materials behind modern power? The oil age was shaped by barrels, pipelines, and tankers. The next age may be shaped by minerals, magnets, and processing plants. Electric vehicles, robots, drones, turbines, and electronics all sit on hidden material foundations. Governments are starting to treat rare earths like strategic infrastructure. Companies are redesigning supply chains before the next crisis arrives. Factories may follow the materials, not just the cheapest labor. New alliances are forming around mines, processing, recycling, and magnet factories. But every new supply chain must also face cost, pollution, and technical difficulty. This is not only China versus the West, it is a race to control invisible inputs. Rare earths prove that the most important parts of technology are often the least visible. The future of modern power may be decided before the final product is even built. China's rare earth weapon is hidden inside the machines that power the modern world. Rare earths prove that the smallest materials can shape the largest industries. The final product is visible, but the power sits in the chain behind it. And whoever controls that chain may control the next stage of global power.